Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS preparation only. In the previous lecture, we have completed our course of Statistics Paper 3, which included five topics, which are econometrics, sampling techniques, and time series analysis, demand analysis, index number. Those were all the topics completed in detail in our lecture videos. If you are looking any of them, then you can rewatch the playlist which has been there on our channel, and you can solve your doubts. If you have any doubts, then you can ask in the comment section or on our WhatsApp channel. We'll solve your doubt as soon as possible. From today onwards, we'll be starting with another paper of statistics, which is statistics paper 1. And statistics paper 1 has many topics, and we'll be preparing for this topic for objective type only, so that we don't waste our time in doing the actual calculation when we have shortcuts. So keeping in mind the shortcuts, so that we can save our time and do maximum number of questions in the examinations. Before that, the objective type of question in objective type of papers, many of the questions can be done by just looking at them and not wasting our time calculating for them. And some of the questions are there, they are just given to waste our time, so that we cannot attempt all of the paper. So we have to ignore such questions. We have to attempt firstly those questions which could be done only just by seeing them, and then we'll do the medium questions which could be done by small portion of calculations that can be done with that. uh, Today we'll be starting with one of the important topics in statistics paper 1, numerical analysis. So numerical analysis is the topic that most of us haven't done in our universities or colleges, because people who were having not having the maths portion with them, they wouldn't have done it before. People would who were having maths portion also would have done small part of it, but not the whole part. And as statisticians and as statistics students, we have done mostly statistics and covered mostly statistics in our bachelor's and in our masters, but haven't done the mathematics portion. So this is one of the major portions that people find very uh, what do we say, difficult. So in today's lecture, we'll be starting the difficult one, so that after completing difficult, we'll be moving forward with the easier, or the as comparative easier topics of the paper. So we'll be starting with statistics paper 1. It has many topics, so we are starting with numerical integration analysis. Numerical analysis. Now, numerical analysis is if we have some numbers, numerical means numbers. If we have some number and we add and subtract some things from that number, then what are the analysis of those? That will be our numerical analysis. Now, adding and subtracting a number, if I have a number 3 and I add 2 to it, then we'll be getting 5. It is direct. What is there to analysis in this part of the question? The analysis is this, that if we have a function of this number, a function of number 3 can be written as fx, and if we add something which is h, both of them are unknown, x is unknown and h is unknown, then what will be the effect on the result of fy? So here we'll be dealing with the functions, not the numbers, but the functions of the numbers that will give a yield an answer. And there are many direct results that we have to mug up. They have been asked directly in the examination, so we can do that as well. So numerical analysis is this only. So it can be defined as the changes that we see in a function, the changes that we see in a function, the finite changes, or we can say the value of a function changes due to finite changes resulting in an independent variable. So if x is an independent variable and I make a change of finite, h is a number or something finite, not infinite, then what will be the change in my value of the function, which is fy. So here fx, the original function was fx and it has become fy due to a small change of h in that finite change, and both of them are x and y are independent variables. So this is our numerical analysis. Now let us take, now we know that y equals to fx. Let y be a function of fx. We can also take this as an equation of x. Y is equals to x plus 2, y equals to x square plus x plus 2, something like this. So y can be a function. Y can be log of x, y can be e raised to the power x, anything, any function of x, y is represented as fx. Now here the this x is said to be independent variable, and this y is said to be dependent variable. What are independent and dependent variables? This we have done in econometrics as well. The variable which depends on another variable for its value, for obtaining its value, is known as independent variable, and the variable which do not depend on any other value and is and exist independently is known as independent variable. These are the two kinds of variable, and here we say that fx is a function of y. So we can also say that. Now independent variable are also known as arguments, and dependent variables are also known as entry. Independent variable are known as argument and dependent variable are also known as entry. So we have here the value of x can be a or a plus h, a plus 2h, where h is a finite change, and so on. Here the values of x can be this. So y can be written as f of a plus function of a plus h plus function of a plus 2h, and so on. This also can be written in y. No plus, it will be commas only. Okay. So we can write this as well. If x has value a, then it y can be written as fa. If x has value a plus h, then y can be written as a plus h. If x has value a plus 2h, then y can be written as a plus 2h. Where a and h is the change, finite change, and a is the original value of x. Okay. Now we'll be moving with differences. What are differences? There are two kinds of differences, forward and backward. So we'll be starting with forward differences. Forward differences is when if I subtract f a plus h minus fa, this will be my forward difference. And this can be represented as a sign delta, which is a triangular shaped sign. And we say that delta of fa can be written as f a plus h minus fa. Similarly, if I change the variable here, if I say delta of fx, then it can be written as fx plus h minus fx. This is our forward difference, which is represented by a triangle or is known as delta. So if I'm saying the forward difference, then the next value of me, if I have three values, 1, 2, and 3. So if I have to find the forward difference of 1, then it will be the next value minus the original value. So it will be 2 minus 1. If I have to find the forward difference of 2, then it will be 3 minus 2. And 3 cannot be calculated because we don't know what is next. Okay. So this is the meaning of forward differences. Now, similarly, we can say that if f a, delta of fa, can be written as fa plus h minus fa, right? And if I say that I have to find delta of fa plus h, then I can say that it is fa plus 2h. The next value will be 2h, a plus 2h minus the original value was a plus h, right? And similarly, if I have to find delta of f a plus 2h, then it will be f a plus 3h. The next value of a plus 2h will be 3. So a plus 3h minus f a plus 2h. And similarly, if we go on like this, we'll be getting delta of f a plus n minus 1 h. This is a smaller bracket. So if I have to find the n minus delta of n minus 1th value, then it will be f, the next one will be nth value. So f a plus nh minus f a plus n minus 1 into h. This will be a process. And this is the first difference. All of these are known as the first difference of any function. Why first difference? Because we are only differencing one time, we are only subtracting one time. The value of every delta here, power of every delta here is 1. That is why it is known as first difference. If we have to calculate the second difference, suppose the first difference of fa is f a plus h minus fa, right? Now if I have to calculate square, means second difference, then what will we do? We have found out this is the first difference. Okay, let us keep it like this only. This was the first difference. If I have to find out delta square fa, then what will we do? We can write this as delta into delta fa, right? We can write this as like this. Delta square can be written as delta into delta, similar to 2 square can be written as 2 into 2. So first of all, delta fa is nothing but f a plus h minus fa, right? Now delta goes inside and it will become delta of f a plus h minus delta of fa. So delta of fa plus h is, we have calculated it before, delta of fa plus h is fa plus 2h minus fa plus h. fa plus 2h minus fa plus h. And minus of delta fa, delta of fa is this, so minus of fa plus h plus fa, because there is a minus sign, so it will become plus. So our final answer of delta square fa would be Next one, so it can be written as minus 2 f a plus h plus f a, right? We have calculated this. And similarly, f a plus, we can also write this as delta of f a plus h minus delta f a. From this one here, this also can be written like this. And in a similar way, if I have to write delta square f a plus h, then I can write this as delta of f a plus 2h, the next term, minus delta of f a plus h. And similarly, if we go on like this further, then it will be delta n f a plus n minus 1 h should be equal to delta n minus 1 f a plus nh minus delta n minus 1 f a plus n minus 1 h. Okay, this will be our formula. So now I hope that you have understood what are forward differences and how can it be written. This was the general concept on forward differences, and from this we'll move on to further new topics, and I hope that you'll understand them as you have understood this. In After this we'll do backward differences and then forward differences in detail, and after which we'll be doing some of the questions from the pyqs as well, so that you will be thorough with the concept as well as how to attempt the question in the limited amount of time. So that was all for today's class. I hope that you understood whatever we are doing in the class, and if not, then you can ask your queries in the comment box or on the WhatsApp channel. And about our Lakshya 2027 program, we have been taking the admissions or inquiries on that. And if you have any doubts in them, then in that course, or if you want to enroll in that course, then you can contact to our WhatsApp number, which have been given in the description, as and when it is required. So, all the best and thank you.